Good morning. My name is Kai Hackbart. I'm with Bosch Software Innovations. I'm also at the board of directors of OSGi Alliance. I'm the moderator for this morning's session. So before we get started with Robert's presentation, the usual stuff. So if you don't have a t-shirt, downstairs at the reception you will find them. There are also socks. Just get them. In addition to this, we have a couple of banners around the location, one here, one downstairs, where we describe use cases, from various member companies that we are realizing with OSGi. So if you're interested in this, have a look. And with this, I hand over to Robert, who will tell us about will it blend Java agents in OSGi?
Thank you, Kai. Welcome to this cooking masterclass with Java and OSGi. A couple of things about myself. My name is Robert Montano. I work with Adobe Research in Switzerland. I am working on our content management experience platform product, and part of that we do a lot of work with OSGi. We have the projects I'm mostly involved in are Apache Jackrabbit and Apache Sling. And I will be telling you about my experiences with Java agents and present to you some code that is part of Apache Sling today. Now, as about the structure, about what we are going to talk today, is I like to start off with a quick demo, just to get things moving, and then we are going to try and decipher exactly what went on. So a bit of a discussion about what Java agents are and what they do, why we should or should not use them. OSGi integration testing is also a very special topic when writing Java agents, and we're going to wrap it up with yet another demo, so nice demo sandwich. Okay, let's get started with the demo actually. Oh, hello Eclipse. Let's quickly restart Eclipse. So I'm going to present the simplest possible application, a Java world. Main class prints out a string on the terminal, and that is it. All right, so I think it's clearly visible there are no tricks here. Right, system out print line, hello world. Now, if I want to run this as a Java application, and then the console should be here not this console. Let's try that again. Run as Java application. The workspace is building. Okay. That was less than expected. Let's stop the workspace build. We don't care about it. Okay, so I think now the console is up. And, well, there's something a bit unexpected here. Now, of course, you know the trick. It's a talk about Java agents, so obviously there's a Java agent involved somewhere. Right, and if we go to the actual launch config, we're going to see that we have a Java agent that allows us to do all sorts of trickery. With that being said, and the stage set, let's talk a little bit about what Java agents are. Now that is a quote from the Java doc of the Java Lang instrument API, and says, well, instrumentation APIs are services that allow agents to instrument programs running on JVM. And by instrumenting, that means you can change the program behavior at runtime in ways in which it was not defined in the program source code. Now, there are two ways of writing Java agents. So the one variation is called static agents. And it's the one that we previously saw, and it means that at startup you add another argument to your Java application. It says, hey, this is my Java agent. Please load this in addition to whatever my program is doing. Now, this requires that in your manifest you declare an entry which is called pre-main class, and you give it a fully qualified class name. And in turn, that one looks a lot like a main class, just it has a slightly different signature. It takes a string, so the arguments are a single string, and an instrumentation. And that instrumentation class is the main entry point to doing anything Java agent related. Then you have dynamic agents, and by contrast, you load this with a running JVM. So there is some Java code you need to run, and say, hey, attached to a running virtual machine, you need to give it the process identifier, you give it the path on disk to the agent, and well, it's loaded, and then you detach for cleanup. That agent that you pass here also needs to have a manifest entry, but it's different. Right now, it's not a pre-main class, it's an agent class. And ultimately, the signature is the same. Well, the arguments are the same, but the name is different. So a couple of notes here. You can support static and dynamic agents both because the signatures and the manifest definitions do not overlap. This API is not part of the, let's call it, official Java API. It's ComSun Tools API. So there is a slight risk factor to that it's not supported everywhere. Although, to my knowledge, in practice, it is supported everywhere. And starting with JDK 9, this API will not allow you to attach agents to the current virtual machine. So you need a second process if you want to attach to this one. So it's a little inconvenience. But in the end, these are the two variations. It's basically the first one is more flexible. It's less flexible. You just give it once to your application, you start, and that's it. And it's quite simple to manage. This one is a bit more complicated to do, but it's also more dynamic. You realize like 2 hours into launching your application that you want to do something dynamic, you attach this agent somehow. Now, the API, you see this add transformer, the new class file transformer here. This is the API that you need to implement in order to transform classes. Quite a big signature. The important parts here are like the class name. So it will tell you which class name is about to be loaded or about to be redefined, retransformed. And then all the rest is more or less boilerplate. You have a class loader, so you can have access to classes which are not immediately visible. We're going to see particularly important in OSGi environments. You have the current class file buffer, so if you want to do just inspection, for instance, and not transform things, or just, I don't know, shift a bit just for fun, you can do that in the current class file buffer. The protection domain is when you're running with the Java platform security enabled, and the class being redefined is, again, a bit of a special case. If you're redefining classes as opposed to intercepting the initial class loading, you will also have access to the class being redefined. And talking about the bytecode, this is, well, a symbolic view of what Java bytecode looks like. So I've printed out the signature, the implementation of a hello world. So if you have this method definition, you have some opcodes being invoked. So first one is get static, and you get a static field from the Java lang system, and you get the out field with a print stream, and then you push a constant, which is hello world, into the stack, and then you run invoke virtual, the virtual method on out, and it's like Java your print stream print line. Now, I've added this to show you that it's great fun to write Java bytecode manually, right? You might do it for a fun weekend project. You definitely do not want to implement all of it yourself. And the bytecodes, of course, the number of like the opcodes change from release to release. The verifier may be getting more strict in new Java versions. So rather than write it yourself, you probably want to use some bytecode generation libraries. I've done a listing here in alphabetical order. It's not an endorsement for any kind of library. The point is to find one which you like as a programming model and is reasonably kept up to date, etc. For my examples today, I worked with Javassist. So this is the implementation of the agent that wrote to the console a bit earlier. This is the body of the transform method, and you get a class pool from Javassist. Now the class pool is, well, what it says it is, right? You have a way of accessing classes that Javassist knows of. And then you get a method from it and say, this is the class name, and this is the method. And you say, let's insert some code here. And this, of course, has to be valid Java code, but the nice thing is that Javassist will compile it for you. So you do not have to fiddle with other bytecode instructions. And of course, the compilation is sort of done at runtime, but I've never seen that be a performance problem, for instance, just adding and regenerating classes. And that doesn't happen all that often anyway. And then you can ask Javassist to, well, please generate a new bytecode for me. And then you detach it, so you do a little cleanup from the Javassist point of view. And well, basically that is it. That is, I guess, the world's simplest Java agent. Of course, there is some boilerplate that you need to look into here. For instance, you need to only transform the class that you want to transform, because you will be invoked for every class that is loaded in the current JVM. But other than that, this is more or less it. Now, this is fun, but we should ask ourselves why. Okay, besides being fun, we need to have an actual good reason for using Java agents. So I try to find out what are people, when we should use Java agents first, and then I'll show you what people are doing. So I think the most important rule is code that you do not control. You do not have the source code for it, and otherwise it doesn't make sense. If you have the source code, just change it, add an extension point. Don't mess with Java agents just because it's fun. Don't do what I did. The second point is no better platform facilities exist. What I'm trying to say that mostly Java agents are a last resort. Whether you're using OSGi or another platform, there probably are various services that allow you to do what you want to do in a simpler way. And usually those are cross-cutting concerns, so you do not have a tiny little piece of code that you want to change. You want to change a global aspect of your application. So as examples, I found plenty of products that do monitoring for you. The kind of thing where they have a hosted instance and they promise to take all your logs or your errors or gather metrics or whatever. And they give you a Java agent that you just drop into your application, and then everything works by magic. And this monitoring agent install some sort of extension points. So whenever something happens in your application, they make an outbound call to the system in question. So that's one class. Profiling is also quite nice, because you can instrument entry points, exit points, define various methods, and then you can send these to a running process, a profiler. And you can also attach them after the fact if it's a dynamic agent. Debugging is a quite interesting scenario if you have an application which has not been properly instrumented for logging, let's say, and you really need to know what happens in a certain method. That you can attach an agent, add some additional logging statements, and well, there you go. That of course assumes that restarting the application is hard, changing, you cannot do a hot deploy and just change that, etc. There's also a tool called Bytecode, I think, which constructs a domain-specific language that allows you to alter the way your application behaves at runtime. So that is sometimes very helpful. Mocking is another cool point. So you have these unmockable things, for instance, behavior of enums, final methods, etc. And you cannot necessarily usually mock them because that's what the JVM says, except if you do what Mockito does and you have an agent which changes the behavior of the application at runtime. You can change the way an enum behaves, for instance. And lastly, you can do, since you can redefine code, you can do various hot swap, code reload things. The JVM already does that if you connect in debug mode, but it has limitations, and it's not, I haven't seen it get improved or developed more in the recent past. So something else which you can do is use an agent. There are a couple that I know of, at least, which allow you to do a lot more redefinition of the code at runtime. Now, here's, yeah, will it blend? Yes, OSGi and Java agents do blend with some caveats, so not everything works just fine. Of course, you need to be class loader aware. That's the first thing you will run into if you create a Java agent in a more or less naive way. So the old code just uses a default class pool. The new code does the following. It takes a class pool which appends the system path and then uses the passed-in loader. So it gets access to whatever classes the loader has access to, which I thank the designers of the Java agent APIs for. And then it also needs to look at the current class if if it's there. So with that being said, it will work for 99% of the scenarios in the OSGi world. Now, of course, there's more to OSGi than just class loaders, and here we run into the new interesting part, which is you will not be able to import packages or get access to requirements that have not been defined in your bundle, which, if you're new to OSGi, will be sort of surprising. There are workarounds. I am not particularly happy with any of that. So you can change the bundle at build time. You can say that you lost and use this dynamic import package star, but it's never a good sign. You can patch additional import package statements to your bundles, but that's also a sign that you more or less lost the modularity battle. So if you're using, if you need to do this, you probably have a scenario where you're better served by other mechanisms, which brings me to the next one. I've been talking a bit before to look into if your platform actually has a mechanism for doing this, and apparently OSGi does, right? You have weaving hooks, which more or less allow you to do the same thing that Java agents allow you to do, but nicer. You deploy your weaving hooks as an OSGi bundle. You register them as using the whiteboard, so you can use declarative services or whatever you're happy for. And it even handles updated bundle package imports for you. The only drawback is that it's an OSGi only solution. And the drawback is obviously if you target something else besides OSGi. But if you only target OSGi, I think weaving hooks are just simply the way to go. And they, to my knowledge, they allow you to do more or less the same thing. Testing is special for Java agents, and basically because of the package requirements, you cannot give it just a set of classes and say, this is my agent. So you must package them and give them a special manifest, and that means if you follow a typical BND or Maven deployment process, you cannot run them as part of the regular test phase, because that only works with the expanded classes. You need to run them later as integration tests. It's not trivial to attach them to the current process, and even if it would be trivial, they sort of taint the current process. You attach the Java agent, you transform the classes, you have one scenario, and then if you want to transform them again, you can start running into trouble. So taking our add something to system out, so okay, that's fine, you can run the agent multiple times, but it will add a second time, a third time, a fourth time, and those are not clean, isolated unit tests. There is no rollback here, and I suppose that is for good reason. It's not a valid scenario for running Java agents. So testing is a bit of a challenge. So usually what you do is you sort of more or less create your own little wrapper or little framework around running external processes. So no longer unit tests, those are more or less integration tests, and you will run a Java process. You will fork your units, your JUnit or whatever test, and you will attach the agent to it. And then you need a separate communication channel. You probably want more than the exit code 1 or 0 or whatever. That usually is not enough. And whether you want to read the system console or open an RMI socket or a web server, that's again your choice. But it's more support, it's more work for you to do. And then you don't get all of the nice things that you usually get with your Maven/Gradle setup, just attach a Java agent. Well, it is a code coverage agent like Jacoco or whatever, right? You need to handle these yourselves. And in the end, it ends up looking like this. So you need to, okay, which Java am I going to get? If you're running a Java agent, which is usually a bit sensitive about Java versions it's running on, so you need to decide, probably you want the same JVM as the one that is running your unit test. So you, sorry, you take this Java home, you get the executable, you need to find the agent jar. And that usually means it's packaged somewhere in your target directory. And again, you need to find the code. And then you need to build a class path, which is your application, the agent, and whatever external dependencies you get. Not rocket science, but you need to do it. And then finally you launch it. You launch the Java, you build the process, and eventually you launch it. And one way of doing this is to just capture standard out and standard in if your agent doesn't do anything terribly fancy, and then read whatever has happened in there so that you know what is going on. If you want to add code coverage, again, that can be done. It's just another agent that you need to download, you need to know where it is, and very importantly, you need to add it before your Java agent, right? Otherwise, it's not going to be to instrument. So again, which works, but I would be happy to not having had to write that additional code. I think there's a ratio of test code to agent code about 3:1. Thank you. So incidentally, things become so much simpler when you test with PAX exam in OSGi environments. I mean, it does all of this forking of an external process, setting up a communication channel, even adding a simple way of adding various external dependencies to your to your launch application. Of course, you still need to find the agent jar, but that is considerably less work to do than just writing the all of that yourself. So in a sense, it is way simpler to do this with PAX exam. So I will go to my second part of the demo, which is briefly about testing. Now there is we have a Java agent which allows you to set timeouts for network calls when the developers have forgotten all about it. And somewhere around here is all of that work that I've been talking about. It's how do you launch an agent, how do you get the standard out, how do you get the standard error, then you parse it, etc. All right, and in practice, let's make this a bit bigger, I think. Behind the scenes, what happens is that it launches a Java agent that has a very long name, and then this is the way you pass arguments to it. And the arguments are basically what is the socket connect timeout and what is the socket read timeout in milliseconds. And then the class path, and then it launches this test harness with a URL and a client library. The agent supports multiple HTTP client libraries. Now, what this kind of testing does is allows you to quickly validate whether a certain timeout is set. So for 1 second connect timeout, this usually works. 1 millisecond read timeout never works. So you get out this nice stack trace that says, well, the read has timed out. And alternatively, if you want to set a very short connect timeout, that also works, and you get a message about network being unreachable, the connect failed. And of course, well, it works with various HTTP client libraries. So we try to cover the bases with HTTP client 3 and 4 and etc. And if you set large enough timeouts for everything, the call should just go through. And this testing harness is basically why the unit tests are wrapping. So I would expect something like this to be more or less a requirement if you want to write Java agents and really test them. All right. So I guess this is more or less it. No, thank you. This is more or less it. If you're interested in how Java agents work, there's the Java Lang instrument. Well, it serves as a good reference. Javassist is the library that I've been using to generate the bytecode at runtime. And in the end, the connection timeout agent as an example of how a Java agent can be written, tested, deployed, documented is also there. So I'm happy to take questions now. Okay, cool. Thank you then.